Hello everyone. So today my name is Christian George-Igbinidu. I'll be explaining object-oriented programming concepts. So object-oriented programming basically deals with two things, classes and objects. Classes are the blueprints in which an object can be defined. Let's say in a school scenario, you define a school class. So the properties and methods you define should be something like so name, the student's GPA, maybe the student ID and student age. Then the methods would be like enroll class, drop course, you know, take health leave or something like that, or take attendance. So once you instantiate a class, that simply means you are building an object, you're creating an instance from it, just the object from a class. You can have multiple objects. Classes are like templates. So in my student scenario, if you create an object of a class student, that object will have all the properties for you to fill out, like your name, age, put the student ID, and the GPA, and the object also has access to the functions you set in the class. So that object will be able to enroll courses, drop courses, take leave, and etc. So that's just the main concept of object-oriented programming. Hello, so today we'll be talking about the concept of classes and objects. So here in this file, we have a class named student. Yes. So in this student class, we have two main things that can be in a class. We have the attributes and then we have the methods. So the attributes are what an object of a class can have. Those are like its properties. So these are like the variables. We call them instance variables, but think of them as just the properties that any object of this class student, let's say student A, which is, let's say my name now, Chris, is an object of student because I'm a student. So these are the attributes it contains. So here, this is the methods. So any object of this class will be able to use this method go school, and simply just prints out the student goes to school. Okay, so we come to this new class. This is just the tester class, or we use the main method to test our code. So in this line, we simply build an object. This is where we instantiate it using the new keyword and the student constructor. More on that in the next lesson. So this is where we build an object. So student S1 is a student. So let me just change it to Chris. So here we have built an object named Chris. So in this Chris object, I can simply type Chris dot. You can see I have the properties of fee, field, GPA, and ID, and even the method go to school that we had here. So when an object is instantiated, it simply just gets all the code and properties of the main class. So this is just the basic concept between classes and objects. So let's test it. So we can set it, let's say set the fee to 505. Now we can print it using the print method. I want to print Chris.fee. And once you run it, you can see the fee has been set here in the terminal. Okay, so if you want to use the method, you can simply say Chris dot. See this go school method. And once we call this method, to simply go here and print out this line of code here. So let's test it. So once we click on run, you can see it prints out the student goes to school. So this is just a basic concept of classes and objects. Classes is the blueprint on how an object should be defined. So everything that this Chris object should contain will be stored in the class. And you have to instantiate it here using this syntax. Then once you call it dot, you'll be able to get all the attributes and all the methods, properties, and everything of the class. So this is just a short concept between classes. So today we'll be talking about the concept of inheritance. So inheritance is simply a class that is inheriting or taking, in this instance, code from another class. So for this example, this is the animal class, and in the animal class, we have three instance variables. We have, because it's protected, we have the set and the getters, setters and getters. This is the constructor. So whenever an animal is created, it will print out this message. These are the methods. So in this second class, this class is a subclass of animal. So in other words, it's inheriting from this animal class, which is also called the parent or the superclass. So here we define this constructor, public class, and we make sure we use this extends keyword. So when you're defining the class, public class cat, we use it extends animal. So that way all the code we have in animal will be available here. Will be available when we instantiate the object cat. So in our tester, we comment out this code. We instantiate our cat class and we create a cat object here. Cat equals to new cat. As you can see, the constructor already has the ID, the color, and the weight from the animal class because the cat is extending the animal. So once this object is being created, the cat now has access to those methods that we defined in the animal class: eat, sleep, move. So as you can see here, let me clear out this code. If we say cat dot, you can see he has access to the attributes and he has access to the methods. So let's say cat dot eat. Once we run this, it will print out whatever we set in the animal class. Print out the animal features are set and the animal is eating. So these two things that I print out is whatever inherited from here. Whatever is here, cat now has access to it when we instantiate it. That means create objects from it. So that is just the basic form of inheritance in Java. A class is inheriting another class. It's taking everything from the class into its own. It helps us so that we don't have to write redundant code. That means we don't have to always rewrite all these methods. We don't have to come into this class and rewrite it. We just have to extend it so that we can use it for the objects. So it's a very simple concept in Java of inheritance, one of the pillars of object-oriented programming. Hello everyone. So today we'll be talking about an OOP concept called encapsulation. So what encapsulation means is like putting all in like one capsule. So like it's like a wrapper, a protective shield. We are wrapping them together. So in this class, if you notice, we used the keyword private for our instance variables. So this concept simply refers to encapsulation. We're protecting it. We don't want every other class to have access to it. Only this class. So we keep it as private. And the only ones we want to allow to have access to it, we implement what is called getters and setters. So here we can see we have set GPA, This allows the user to set the GPA, but of course we don't want that. So we can comment out the code. So all we want the user to do is to get his GPA. So this is the process of encapsulation. Protect it from other classes. So because if we had the user to set his GPA, the system will be compromised. So we have to find a way to protect our code from other classes. That's why we use this private, which is also, and this concept is called encapsulation. Okay, so inside our tester, we have an object now of class student. So let's call this Chris. Now, if we try to set the GPA, Chris does set GPA to give you error. It doesn't know what method is this, meaning we can't implement it. So all we can do is to get the GPA, Chris.get GPA. So if you, and the GPA that was originally set when we were creating the object is 3.5. So the output should return 3.5. This is the GPA. So using what we just learned, this is a way to protect our code from other classes. We can have private methods, we can have private instance variables. So the only, if we want to allow access to the user, we use getters and setters. So encapsulation is just simply a way to protect our code from other users. You'll be the one to control access to what levels users can get to your program. So in this case of students, we can't allow students to set their GPA to compromise the system. So the only thing we can allow is them to get their GPA. We cannot change the ID. Once their name is already set, okay, maybe we can make changes to the name. But moreover, we cannot allow them to set their GPA. We can only retrieve the GPA. So this was all about encapsulation. So polymorphism basically means more than one, and in Java sense is these methods. So there are two aspects of polymorphism. We have method overloading and method overriding. Method overloading happens when you use the same method name, or you can have different parameters, different return types, and etc. While method overriding happens when a method is overriding a method, probably in different classes. So, and method overloading happens in compile time, while method overriding happens in runtime. So we'll be seeing them now. So an example of method overloading will be here. We have public fish, which is the constructor method, and we have two of them here, but they have different amounts of parameters. So here we can tell it's compile time because we already know exactly which one will happen as well compiling the code. So let's say we're creating a second class, fish2 equals to new. You can see the methods here. Either you choose this or this. So it really depends on which one you want. So it also has different aspects to it. Like another one, we have method overriding. For example, in this animal class, we have the method eat, sleep, and move. So in the fish class, you can override it like you see it here. Method overriding. The move, then system.out.println, the fish is swimming. So once you click run, the fish that move will show the fish is swimming. Originally, it's supposed to show the animal is moving, but the method has been overridden here. So basically, this concept is called polymorphism in Java. It falls in having multiple methods that either they are overloaded or they are being overridden. So that is just the basic aspect of polymorphism. There are two aspects: method overloading, which is having the same method in the same class but different parameters of different return types. By method overriding, let's say in the main class we have a method, then one of the subclasses can override it. That is the concept of method overloading and method overriding, which makes up polymorphism
Hello.
in
So
Java.
today I'll be talking about concept of abstract classes. What is abstract class? An abstract class is a class that cannot be instantiated. So once we use the modifier abstract, it means that this class cannot be instantiated. You can't create an object from this class. We did it because there are two types of students. It can be an online student or an in-person student. So both of them will be extending students rather than being able to create a class of, to create an object of students. We don't want to be able to create an object of students, so we give it abstract class. So in this in this second class, the online.java, we see it extends students. So that way we can directly know the type of objects we're trying to create. Is it an online or an in-person student? So in the constructor, we always reference the super constructor because we're doing inheritance here. But in abstract, we cannot instantiate this. In our tester, if we write student s1 is equal to the new student, so we're trying to instantiate it, we can see it gives us an error. It says cannot instantiate the type student because type student is an abstract class. So that is very important thing to know about abstract classes. Abstract classes cannot be instantiated. Another concept goes to abstract methods. Like here, you see public abstract void do COVID test. So in our student class, basically for all students, we want them to implement this method. We use abstract. So abstract methods must be implemented, unless your code will not run, you get error. Abstract methods must be implemented. So as you can see, when this online on Java is extending students, if where is it? Let's say we remove this. If we have just a normal class like this, to give you an error, say the type, what is it? Say the type online must implement the inherited abstract method student.do COVID test. So the best way to do it is just to use the methods public void do COVID test. Online students should do COVID test. So we implement the method. So another way to bypass implementing the method, the abstract method here, we can just name this class an abstract class. And in turn, any subclass that is extending online student must implement this method as well. This abstract method from the main parent class. So that is just the main concept of abstract methods. If you don't implement it, it will give you an error. Type online the Java must implement the inherited abstract method. So that is the concept of abstraction, abstract classes and abstract methods.
Hello, today
Thank
I'll
you.
be talking about interfaces and how they work. So let's take this scenario. We have a student class. We define our student class code. We have the constructor, we have the getters and setters, we have the toString method, and we have some other functions such as enroll. Then we have another class, student employee. So as you can see here, it says public class student employee extend student. And from our class inheritance, we know once we are extending a class, all these methods will be accessible here when we extend the class. So here we can see it implements employee. What does this mean? So in the employee class, it's an interface. And an interface can only have methods. It doesn't have any instance variables, doesn't have constructors. It just only has methods. And these methods must be implemented. Otherwise, if you take it and let's say leave and receive salary, mm, yeah, leave and receive salary. If you comment it out to give you error because it said type student employee must implement the inherited abstract method employee.leave. So it's always very important to note interfaces have methods that must be implemented. So if you create a class that implements this interface, it must always be implemented. For example, in our tester class, once we have created this, instantiated the student employee class, we can see that std employee dot, you can see it has all the methods available because in its class, it's extending student and implementing employee as we see in line 3. Extend student and implement employee. So here in the tester, we have access to every of these methods. So if we want to do receive salary, we have it there. So once you run it, why is it showing us error? Mm, Okay, so we're back. So let me comment this out. So if we try student employee to receive salary, it should run the method just fine. So basically, the main thing we have to understand is you create a class and you put instead of having it class, you change it to interface. And interface can only have methods. Here we can see abstract methods, which means that any class that implements it must fulfill the methods that it has, must define the methods. Sorry. So that's just basically everything for interfaces.